Hi, welcome back to a new video. A few months ago we made a very detailed video about Corsair's IQ-Link QX fans. Not only because they had some new and very interesting technical features, but also because they were quite pricey with about $50 MSRP. Meanwhile, they dropped a little bit, so at least in Germany they cost about 43 euro. So they became a little bit cheaper, not too much, but now Corsair launched the RX fans. And then looking at the specs, it seemed like that the RX fans are not only quite a bit cheaper, about $15 cheaper, but might also be better than the QX fan, which seems to be quite an odd choice. And we already saw them briefly at CES, but we were not able to test them, obviously. So today I want to take a closer look at the RX fan and look at some technical details and maybe also an interesting marketing aspect. Because if you're planning to build a new PC, then it's always important to select the right fan for your system. And talking about building, maybe you also want to build a new website and need a right selection. This video is brought to you by Squarespace. Whether you're already running a business or you're looking to create your very own hardware review website, Squarespace is your go-to website to create it within minutes. You can either start with traditional templates or try their very easy to use Squarespace Blueprint AI system. Simply describe your topic with a few sentences and AI will set up the base structure for you. Afterwards, fill it with your own content, products, images or videos. If you're planning to sell items or maybe digital services, Squarespace will make it very convenient for your future customers because they support all important payment options such as credit card, PayPal or even Apple Pay. Once your website is up and running, the built-in SEO tools will help to increase visibility and keep track of your success. Squarespace offers a free trial, so click on the link in the description below and try it today. Once you're ready to go, enjoy 10% discount with my link for your first purchase of a website or domain. If we briefly compare the specs of both fans, the QX120, the expensive one, 2400 RPM max, and at this fan speed 63 CFM. The RX120, 2100 RPM max, so that's 300 RPM less, but at this speed 74 CFM. That means that the RX120 will spin at 12% lower speed, but at this lower speed also have 15% more performance. That is quite odd and interesting. But before we take a look at these, I just want to get some baseline numbers first, so I prepared some other fans for comparison, and I will show you how I'm going to test. I decided to go for these fans. I think they're quite popular options. That's the Noctua NF812. We have the Fantex T30, the SET QX120, and also the Arctic P12 Max. Here this is the RX120, but in the non-RGB version, just all in black, as I said before, same one that we saw already at CES. And here you can already see the QX120 RGB, and that's also going to be our test setup. It's pretty similar to what we tested last time. It is just a static setup. That means you can neglect that I'm running DirectDi, whatever, it doesn't matter. The CPU is set to a constant power limit of 160 watt. So I will run Prime 95 in the background, which means that the CPU will constantly dissipate 160 watt of heat to the radiator, and then depending on how strong the fan is and how much air it can push through, it will result in a lower water temperature. And then in the end I will measure the delta, the temperature delta between the water temperature, which I will measure in here, to the ambient air temperature. Similar to previous tests, we will have two different test criteria and measurements. The first one will be that all fans will spin at 1000 RPM. That also means they're all going to be rather quiet, which means that I will record the noise level from 10 centimeters distance, which is really close. But it's required because otherwise I'm not sure if some ambient noise will have an impact on my results. And with the first measurement, we can then compare the noise level and also the temperature. The second category is going to be the fans at 40 decibels measured from 30 centimeters distance. And that's also, at least from my personal preference, the more important value, because I don't really care how fast a fan is spinning. I just want to see that it's performing well and it's not going to be loud at the same time. So I think the noise normalized testing is going to be more important. Those are the comparison numbers that I measured with the 4 comparison fans. First scenario, as I said, 1000 RPM fixed. We see the Fantex T30 with the strongest values. The temperature delta between water and temperature in this case is 17.1 degrees Celsius. You can see this in the blue bar. The yellow bar indicates the noise level, which in this case is 36.5 decibel for the T30. The Noctua NF812 is on the same noise level, but is about 1.8 degrees Celsius worse. The Arctic P12 Max is again a little bit worse with about 22.5 degrees Celsius, but at the same time also pretty quiet. If you compare all that with the QX120 that you can see on the bottom, that costs 43 euro. That fan is just not good. Performance-wise, it's not good, 23.2 degrees Celsius, and it's also the loudest with 38.4 decibel. Moving on to the second scenario, as I said, again, the Fantex T30 is dominating. At 40 decibel, this fan can spin at 1640 RPM and is causing a delta of 11.8 degrees Celsius. Noctua NF812 about the same RPM, but has a delta of 13.2 degrees Celsius. And again, in this scenario, you can see that the QX120 is all the way on the bottom. It's not a good fan performance-wise. 1400 RPM are possible at 40 decibel, and it will result in a delta of 19.7 degrees Celsius. Now the RX120, which is a completely different fan compared to the QX120. We can also take both fans next to each other and you will see they're completely different. The fan blade is completely different. On the RX120, the diameter is bigger. You can see this is quite a bit smaller, which is caused by the RGB ring around it. Also the geometry, the angle, everything on the QX is different to the RX. And also if we turn it around, you will see this one has 4 big things and also the temperature sensor right here, whereas this one has a very thin structure, also angled structure, which apparently also affects the performance of a fan a little bit. Apart from that, both are IQ Link fans. So you have those connections right here, the physical connection, and right here the PCB connection for electrical wiring. You could see the example here. So if you want to make the electrical connection to another fan daisy chaining, you have to enter this one. And for just the physical structure, you add one of these. Then you can just connect 2 fans with each other. Well, you probably wouldn't connect a QX with an RX fan, but if you would do this, then you can connect 2 fans with each other. And if we compare the non-RGB to the RGB fans, I also did some measurements and both look identical. There seems to be no difference between both of them, even though they seem to be made out of different materials. I also checked things like the gap between the blade and the frame. For both fans, it's pretty much exactly 0.8 millimeter, which is also an indication of how accurate the fan is made and also indicates the quality of the fan. But yeah, you cannot compare it to the QX. It's completely different, but these two seem to be identical. My assumption that both fans are almost identical is what you can also see in this result. Both RX120 fans are also beating the QX by a lot. At the same speed, the RX120 even beats the Noctua NF812, but is also about 3.5 decibels louder. Compared to the QX, the water temperature is decreasing by 5 degrees Celsius. The rather high noise level is also what has a huge impact on the second measurement, where the RX fans can only reach a max of 40 decibels. And at those 40 decibels, they are spinning at around 1300 RPM. And in this scenario, resulting of a temperature drop of around 3.5 degrees Celsius versus the QX120 fan. So that's already a good improvement. But if you look at Fantex, Noctua or Arctic, these are still a lot stronger at the same noise level. On the RX120 RGB, you can see that Corsair tried to maximize the blade diameter, which you can see by the frame having almost no material left here. And also you can see this RGB part right here is already exceeding the frame on the outside, which is totally fine, no problem with that. But due to the high fan blade diameter, this is going to increase both the volume but also the noise level. And talking about the noise level, I also noticed that the fan itself is making, I wouldn't say an unusual noise, it's not damaged or anything, but you can hear like a clickering noise, something like that. That's just something I noticed, so I will point my microphone on here so you can see what I mean. And also talking about the noise and the fan, how it's built, it should have a magnetic bearing. Corsair is definitely going in the right direction, especially compared to the QX120 fan, which is definitely not a good fan, especially if you take a look at the performance compared to the competition. It has technically interesting features, but performance-wise, it's just not good, especially compared to the price. But the RX120 is doing a lot better. also being cheaper at the same time. Still, some fans from the competition are better than even the RX fans, and also still, depending on the fan, also cheaper. There's one more thing that I noticed already during CES when Corsair told me that this is an LCP fan. LCP means liquid crystal polymer. That is the material the fan is made of, and that's something you probably know for years already, especially after Noctua did some heavy marketing around their NFA12 that is made of this type of plastic. But I will show you something on the camera first. If you take a look at Fantex T30, you just tilt it a little bit in the light, you will see that it has a very special surface structure, and that is due to the glass fibers of the LCP material. It's the same for the Noctua fan. They will definitely use different types of LCP. There are different vendors that are making the LCP for the fan makers, and you can buy them from different manufacturers also with different types of filling rates for the glass fiber. So one fan might have like 30% glass fiber, the other might have like 40% glass fiber. So definitely they will be different types of plastics in the end, but the base material will be LCP. And you can see by just the surface structure that this is a different type of plastic than, for example, compared to the Arctic P12, which is probably PPS or PBT, something like this. And if we take a look at the RX fan, cannot see any of this specific, the glass fibers that you can typically see with LCP. The interesting part about all of this is that typically LCP is only used if you're going to make a high-end fan, because it has some advantages, such as if your fan is spinning very fast, that the length or the change of length of the blade is not that significant, and also the change, not sure how to say it, but the way that the blade bends in itself is just a little bit less with LCP. And that is something that is interesting with the Fantex T30, because that is the natural type of LCP. The natural type of LCP is gray, and also with a high amount of glass fiber. That's why this fan has this very specific design it has, because it's the natural type of LCP. And whenever you try to modify the LCP plastic, you add, let's say, something that makes it black, you will decrease the mechanical strength of the LCP material. And then depending what kind of modifications you do, it might be that your LCP type is not much better than other plastics. And that leads me back to the RX fan, where if you compare this type of fan, the RGB fan, with the LCP fan, the non-RGB fan, the RGB fan is made out of this typical material that you see on RGB fans, which is PC type of plastic. And that is a rather cheap plastic, but it works very well for fans, especially if you want to have a nice view of RGB. This fan, which is apparently made of LCP, has exactly the same dimensions. Everything is the same, so they probably even use the same injection mold for both fans. Which leads me back to the question, why would you use LCP on this? Makes zero sense, because LCP is a much harder to work with material, and it's also much more expensive. That's the reason why you only use it for high-end fans if you can even make use of LCP the way it is. Otherwise, you can use other types of plastics like PBT or whatever that might have the same physical strength but might be a lot cheaper. So I think in this case, it is just a pure marketing thing that they maybe went for LCP. I have no way of telling if it's actual LCP or not. It doesn't really look like typical LCP, might be with very low amount of glass fiber, but yeah, don't be fooled by this. The LCP won't help you anything on this fan because it performs exactly the same as the PC fan, and the PC material would be a lot cheaper than LCP. So much about a little bit of material science around fans. There will be a big video probably next week where we visited a fan factory in China. It's going to be 30 minutes of how fans and heatsinks are made. I hope you enjoyed this video. See you next time. Bye bye.